Right, hello again grade 12s. This is the last little section to finalize differential calculus, and it's specifically called calculus of motion. Now before I start the discussion on calculus of motion, you need to understand that they discuss calculus of motion with physics students quite a lot. So the people who do physical sciences, you guys will actually find this section incredibly easy to do because most of these concepts will be very, very familiar to you. For those of you who don't do physics, please don't go and stress and now think that you're going to be disadvantaged because you don't do physical sciences. You'll see the way they ask it is they try and ask it in such a way that you don't have to go and understand the ins and outs of motion in order to understand the calculus of motion. So there are a couple of stuff you can just kind of learn off by heart and make sure you understand that. But mostly you'll see just later on what they try and do is they then try and go and instead of talking about calculus of motion, they try and relate this back to rates of change, which is the previous video. So just try and follow along. I'm going to say some important stuff, especially for those of you who haven't done physical sciences for the last 3 years. Okay, so let's get started. Calculus of motion. Now, calculus of motion starts just with an idea that you have something called a vector. Now again, for those of you who don't do physical sciences, please don't stress about understanding vectors. It's just, for you guys, it's going to be mostly terminology. So mostly we talk about distance in mathematics, but now sometimes they're going to talk about something called displacement, which is effectively sort of the same thing. The physical sciences people will realize it's not the same thing, but we'll talk about the differences just now. Then instead of talking about speed, as we have so far spoken about in mathematics, they talk about velocity. And then acceleration, where there isn't really another name for acceleration. Acceleration is something that you guys should at least have heard of somewhere before. Okay, so please just, the first one is the terminology. We could be talking about displacement instead of distance. We could be talking about velocity instead of speed. Now, the biggest difference here between distance, displacement, speed, and velocity has to do with the fact that speed and distance are always positive. Whereas displacement, velocity, and acceleration can be positive or negative depending on direction. And that is an important thing that you guys need to realize, is sometimes you're going to be calculating displacement and you're going to end up with a negative answer. Now before in mathematics, whenever we calculated distance and we ended up with a negative answer, we kind of threw that answer away because we said distance can't be negative, which is correct. Distance can't be negative, but please be careful, displacement can. And we're going to look at that in examples where sometimes a negative answer is the correct answer because it refers to the direction of that. So an example could be something like, for instance, if displacement is positive going forward, then a negative displacement just means you're going backwards. Or if velocity is positive going up, then a negative velocity just means you're going down. It's very much that simple. Okay, now very important. This is something, especially if you don't do physical sciences, you need to go and you need to study this off by heart. The physical sciences people, you should know this, but you pretty much know this in a different format. So it's also important that you guys concentrate and just pick up on this. Okay, so they use different letters in order to indicate displacement, velocity, and acceleration. So displacement is normally represented by an S. Okay, again, don't stress, you don't have to remember that. In the problem, they're going to have to state that S represents displacement. So S represents the displacement with respect to time. So S represents the displacement with respect to time. Now, very important, we are then going to go and we're going to say, but then I have something called velocity. And velocity, this is the part you have to memorize, is going to be the first derivative of displacement with regard to time. Meaning, if I find the first derivative of displacement there, whatever that formula is that gives me displacement or distance, if I find the first derivative, that's going to be my velocity. And the biggest reason why the first derivative of displacement gives me velocity is because velocity is normally measured in physical sciences in meters per second, which, if you think about that, that is a rate of change. So that is the rate of change of displacement in meters with regard to time in seconds. So because it's a rate of change, it means it's the first derivative. So you have to go and you have to memorize that velocity is going to be the first derivative of displacement. Then acceleration is also a rate of change, but this one is going to be the rate of change of velocity with regard to time. And that is simply because normal acceleration in physical sciences gets measured in meters per second squared, which means it's pretty much meters per second per second. That's what meters per second squared indicates. It's meter per second, which means it's the rate at which the velocity changes with regard to time. So that's going to be the difference in velocity over the difference in time, or you could actually go and say it's the second derivative of displacement. So pretty much what you need to understand here very carefully is you need to understand that if I have displacement or distance and I want to get velocity or speed, I need to find the first derivative of displacement time. Then if I want to go and find the acceleration, that's going to be the second derivative, or if they start by giving me a formula for velocity, then the first derivative of velocity over time is going to be my acceleration. So this is just something you need to memorize. You need to be very, very, very clear the fact that you understand velocity is the first derivative of displacement time, acceleration is the first derivative of velocity time, or it could be the second derivative of displacement time. So please, people, get that very firmly entrenched in your mind. Okay, let's start looking at some examples. First example is from the textbook. It's example 1 on page 237. It states, a projectile is shot up into the air from the top of a cliff. So they say we're going to go and we're going to stand at the top of a cliff, and a projectile is going to be fired up into the air like this. Now, obviously, if I fire that projectile up into the air, it's going to come down past that height of the cliff. Okay. Now they give me the following formula. S, which normally indicates displacement, is equal to 100t minus 5t squared. And like I explained to you guys, you don't have to memorize that S represents displacement, because they always have to explain to you what the variables are standing for. So the first variable, S, is displacement in meters, and then t is time in seconds. And very important, upward direction is positive. So just for the physical sciences people, don't complicate these problems. In mathematics, they're trying to keep it as simple as possible. So obviously, because the upward direction is positive, this does not refer to the full displacement. It just refers to the up-down displacement. In other words, how high above the cliff it goes, that's going to be my positive displacement, or how far below the cliff it goes, that's going to be my negative displacement. That's pretty much all it indicates. So we are indicating pretty much height here when it comes to S. Okay. Now, just a quick comment before we do this example. We need to talk about something called my initial displacement, and then we also need to talk about something called my initial velocity. Now, initial displacement refers to before anything happens. So before this projectile, which I think in the textbook they draw a little diagram of a cannon, which looks like that you're firing a cannonball up into the air. So before anything happens, they are going to ask me, what is my displacement? Meaning, how high above the ground is this cliff? Or in this case, it won't be how high above the ground is the cliff, because they said it's from the top of a cliff. Okay, so I know this sounds a little bit confusing, and I apologize for that, but let's just quickly talk about initial displacement. So with regard to initial displacement, we are talking about S, and initial displacement will always happen when t is equal to 0. So the moment you see this word initial right there, the word initial refers to the point where t is equal to 0. So please just remember that's where t is equal to 0. So if I put 0 in there and I put 0 over there, obviously you get an answer of 0. And the reason you get an answer of 0 is they went and they said right over there, right there, is where you start firing. And you have to remember that this displacement talks about the height above or the height below the cliff. And that's why the initial displacement is 0. Because initially, you are 0 meters above or 0 meters below the cliff. Okay, so that's why the initial displacement there is 0. A lot of people might have assumed the initial displacement is going to be the height of the cliff, but that's not how they defined this problem. So based on how they defined it, the initial displacement is 0 in this case. Okay, now let's talk about the initial velocity. Again, initial velocity, the word initial always indicates this is what happens before anything else. So this is what happens where t is equal to 0. But now they're talking about velocity. And because they're talking about velocity, we have to now find the first derivative of this formula. Because velocity, like I explained to you, is then the difference in displacement over time. So that means the velocity here is going to be equal to 100 minus 2 times negative 5, so negative 10t. And then if I want to know what the initial velocity is, in other words where t is equal to 0, the initial velocity is going to be 100 minus 10 times 0, which is then going to be 100 meters per second, which just pretty much means that when this cannonball is fired from the cannon, it starts traveling at a velocity of 100 meters per second. So that's just the initial velocity. Okay, by the way, in the example, if you look in your textbook, they actually stated the initial velocity is 100 meters per second. They didn't ask you to calculate it, but I just wanted to explain to you what the terms initial displacement and initial velocity refers to. Now let's look at the questions that they actually ask. Right, so first question. They ask, what is the velocity after 5 seconds? Now, we've spoken about this. Velocity is going to be always that first derivative of displacement time. So we know that we've already gotten that, and the velocity is 100 minus 10t. But the moment they ask me the velocity after 5 seconds, I can then substitute the 5 into t to get the instantaneous velocity after 5 seconds. So the instantaneous velocity after 5 seconds is going to be 100 minus 10 times 5, which is then going to be 100 minus 50, which is 50 meters per second. Very easy, simple and straightforward, but like I said, you had to know that to get velocity, you don't substitute into the original displacement time formula. You have to go and substitute into the first derivative, which is the velocity formula. Then the next question says, time to reach the maximum height above the cliff. So again, we see that word maximum. And the moment we read maximum, we go and we say, oh, okay, maximum is going to be with the first derivative. In this case, it was that ds over dt, which we've already said is my velocity is equal to 0. Now, the physical sciences people will understand this hopefully better, but I mean, it's not that difficult an idea. The idea is just pretty much that what you're doing is you are firing this cannonball out of the cannon, okay, and it's traveling. Now, initially it starts traveling at 100 meters per second, and as it goes up, gravity impacts on how that projectile travels. So gravity goes and it slows down that upward motion until eventually the cannonball stops. For a split second, stops before gravity goes and it pulls it. Well, it's pulling it down the whole time, but gravity eventually kind of wins, and then it starts falling down to the ground. And just before it starts falling down, so just before the gradient becomes negative, or just before the rate of change becomes negative, so starting to fall down, we reach that maximum height above the ground. Or above the cliff, I should rather say, because remember they defined the displacement as being the height above the cliff. Okay, so that just means where the velocity is 0, so where it stands still, that's where it reaches the maximum height above the cliff. So we're going to take this one again, the 100 minus 10t, and we're going to set that equal to 0. And then we're going to say minus 10t is equal to minus 100 and divide both sides by negative 10. T is then equal to 10 seconds. So after 10 seconds, this projectile reaches the maximum height above the cliff. Now they ask, what is that maximum height above the cliff? And that should be pretty obvious. If after 10 seconds we reach the maximum height, we then go and we substitute it back into the original equation, because the original equation is what gives me the displacement above the cliff. So I always have to go and substitute back into the original there. So S is then equal to 100 times 10, because it reaches that maximum height above the cliff after 10 seconds, minus 5 times 10 squared. So that's going to be 1,000 minus 500, which is going to be 500 meters. And obviously that's 500 meters above the cliff. So if I go back to this original little drawing, it gets fired at an initial velocity of 100 meters per second. It goes up, 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 and at 10 seconds it reaches over here that maximum displacement, specifically above the cliff, of 500 meters. And specifically 500 meters above the cliff, and then after 10 seconds it starts falling down, and then obviously it's going to go and fall down, and at some point in time it's going to have a negative displacement. Why? Because it's going to dip underneath the original height of the cliff. Okay. Now the next question then asks, what is the velocity after 15 seconds? So again, velocity, we substitute into my first derivative. So that's going to be 100 minus 10 times 15. Now this one is going to be 100 minus 150, which is negative 50 meters per second. Now that negative 50 meters per second just indicates that at that point in time, this projectile or cannonball is falling down. Because again, if you look at the diagram that I drew over here, initially it's got a positive gradient, so a positive rate of change, so a positive velocity, meaning it's moving upwards. It reaches its maximum height above the cliff, and then after that, so after 10 seconds, it starts falling down, which means it's got a negative rate of change. It's got a negative gradient, which means it's got a negative velocity. And that's what changes from speed to velocity. A speed can't be negative, but velocity can definitely be negative. Okay, next question. The next question they ask, what is the displacement after 30 seconds? So displacement after 30 seconds, we go back to the original, because remember S indicates my displacement, and that's going to be 100 times 30 minus 5 times 30 squared. So I'm going to be lazy and just use the calculator over here. So it's 100 times 30 minus 5 times 30 squared, which is going to be minus 1,500 meters. Now again, people, I know it's really strange to have a negative, but it is definitely possible to have a negative displacement. And again, this is where this diagram just helps so much for you guys to indicate that any positive displacement means above the cliff, whereas any negative displacement means below the cliff. And that's actually the question they asked next. Oh no, they didn't ask it in this particular problem. I was thinking about a different problem, where they could ask you, please interpret this particular question. And this particular question just means it's 1,500 meters below. So not above the cliff, it's 1,500 meters below the cliff. That's pretty much what that negative value means. Now the next question then asks for acceleration, and we did speak about this right at the beginning, where I said to you guys, if I want to find velocity from displacement time, I find the first derivative. If I want to find acceleration from displacement time, I have to find the second derivative or the first derivative of velocity time. So in this case, acceleration is going to be dv over dt. And remember, I wrote that one down over here where I said the velocity is 100 minus 10t. So the acceleration is then going to be equal to, be careful, you'll notice there 100 is a constant, so the derivative of 100 is 0, but the derivative of minus 10t is minus 10. And that's going to be minus 10 meter per second squared, which, by the way, the physical sciences people, you might be a little bit upset about that because that's not exactly accurate. Gravity is always minus 9,8 meter per second squared, but this is roughly accurate. Whereas for the people who don't do physical sciences, you don't really need to understand the whole concept of gravity. You just need to go and understand that whole idea, and a good way to explain it is just like this. There's displacement, there's velocity, there's acceleration. And if you want to move from the one to the next, you just have to go and you have to calculate the derivative. That's one of the best ways to explain it. So if you have displacement time and you find the first derivative of displacement time, you get to velocity. If you have velocity time and you want to get acceleration, you just have to find the first derivative of velocity time to get to acceleration. Or you can do a jump like this and you can say the second derivative of displacement time is going to be acceleration. And that's pretty much the idea that you need to understand over here. We will obviously do some more examples. The good news is they don't really ask this calculus of motion very often. It is in the syllabus, so we have to discuss it with you guys, but in the last couple of years, especially if you've been working through that differential calculus revision worksheet, you'll see that calculus of motion and rates of change are very rare indeed. Okay, thank you for listening.